All right, guys, so let's see how we can tackle this. Hopefully, you'll find this more exciting because now the math actually means something. So it says, suppose that the water wheel in the figure to the left rotates at 6 revolutions per minute. So underline that. 2 seconds after you start a stopwatch, point P on the rim of the wheel is at its greatest height, 13 feet above the surface of the water. Okay, that makes sense. The center of the water wheel is 6 feet above the surface. All right, does everyone understand what's going on? We have a water wheel. It looks like it's rotating counterclockwise, and that point P at the highest point is 13 feet above the water, and then at the lowest point, it looks like it's 1 foot below the water because the radius is 7 feet, and it tells me from the center to the surface of the water is 6 feet, so point P will be 1 foot underneath water at some point. Does that make sense to you guys? All right, letter A. Sketch a graph of D as a function of time, t, in seconds since you started the stopwatch. All right, so let's sketch. Y-axis, t-axis. The biggest point P will ever be at is 13 feet. So I'm going to put 13 like so. Dash lines. I'm never going to go above that. The middle is, water wheel is 6 feet above the surface. The middle is 6 feet. So I'm going to say 6 feet is like right here. Sorry. Force a habit. And then point P will be 1 foot below the surface of the water. So the surface is the x-axis. Are we still okay? All right. 2 seconds into the stopwatch, I have a high point, so I'm going to say 2 seconds is right here, and put a point at 2:13. If you're doing 6 revolutions per minute, that means you're doing 1 revolution every how many seconds? Every 10 seconds. Is everyone okay with that? What's up? Oh, 2 seconds after you start a stopwatch. So every 10 seconds, point P is at the highest point. Does that make sense, guys? So I'm going to say that this is 10 seconds later, so at 12, put a point at 12:13. And then keep the distance symmetric, right, or consistent. So I'm going to say that's 22. At 22, you're at 13. So there it is. I have 3 peaks in here. Are we still okay? Oh, yeah. What's up, miss? I can write more peaks if you want to see more. I can put like another one right here. It just depends how many you want to see. You know what I mean? If you want to see the whole minute, you can put 6 peaks. Now, in between your 2 maximums, right smack in the middle, your 2 max, you have a min. Does that make sense? So go 5 seconds after the 2, or go just right to the middle at 7 seconds, and put a point at 7, -1. Do you see how we did that, guys? Then go to 17, -1. And if you want to put another one, 27, -1. Notice that all the minimums are 10 seconds apart. Are we still okay? All right. In between the max and the min, you have a point of inflection. So just to be consistent, I'll show you the first 2 where the times are at. Let's see. The difference between 2 and 7 is 5, so I'll go 2.5 seconds. So it's going to be at 4.5. At 4.5, put a point of inflection. So right at the midline, 4.5, 6. And then 7, 8, 9, 9.5, 6 again. Those are the only 2 that I'm going to go ahead and put the labels on. Go ahead and do the others, but I'm not going to put the label because I don't want the t-axis to be all crowded. So in the middle, bam, middle, bam, middle, bam, middle, bam. Are we still okay? Yeah, it's a sinusoid because it just goes up, down, up, down, up, down. All right. The max put bowls upside down. The mins put bowls and try to connect it. Try to make it where it changes inflection right at the point of inflection. Concave up to concave down and vice versa. It doesn't have to be perfect, guys. Yes. The number between 7 and 12 is that's 9.5. And there you go. You just describe the behavior for point P at any time t. And that's just one example. There's so many that the number of sunspots on in the sun is sinusoidal. But you guys knew that, right? Maybe. And there it is, guys. Let's see what else they want. Letter B. Assuming that d is the sinusoidal function of t, write a particular equation, confirming by graphing that the equation gives you the graph you sketched in part A. All right. I can use any equation for sinusoids I want. I can use a cosine or I can use a sine. Which one do you think is easiest to use? The cosine. You can actually use the sine, guys, because we actually have the point of inflections, but it's always easiest to use the cosine because I can move that peak to whatever I want. Does that make sense? So I'm going to go ahead and write y equals a cosine, giant parenthesis, b, open parenthesis again, x minus c, close, close, plus d. And then I'm just going to insert those values, guys. The midline, the 7 or the 6? The midline is 6. So d is 6. The amplitude, the distance from 6 to 13 is 7. The b, so 2 pi divided by the period, which is 10. So that reduces to pi over 5. And then finally the c, what's my shift? 2. If you want to say 12 or 22 or 32, that's fine, but usually want to use the one closest to the x-axis. And here's my equation, guys. Y equals 7 cosine, open parenthesis, pi over 5, open another one, x minus 2, close, close, plus 6. When you get to the university, depending on the professor, they might distribute the pi over 5. Don't get scared. If you see pi x over 5 minus 2 pi over 5, 7 cosine parenthesis close plus 6, it's the same thing. Cool? Okay. So here we go. Do you guys have a calculator with you? For Black Friday, if you guys want to request a calculator. I'm not a seller, miss. I do have probably like combined maybe like a 10 calculators somewhere all over my house. There's junk in the calculator, so I would clear them. Oh, that one doesn't have any batteries, I don't think. Oh, there's batteries now? Yeah, you don't want an 84? You want an 84? Why not? No, I don't. Is there battery? I don't think it has battery. All right, here we go, guys. Go to y equals. If you have an Inspire, you're going to have to open up a menu and then add a graphing. And type in the equation that we just had. 7 cosine pi over 5. Open parenthesis, x minus 2, I think. Close, close, and then plus 6. There it is. So does yours look like that? I don't see any mistakes, guys. Don't push graph yet. You want to fix your window. So there's a button that says window. You just push it. Let's see. Let's go from -1 to, what do you want to go? 32? I don't know. We want to at least see 1. You know what I mean? Like 1 spike. Because it's every 10. Yeah. X scale. No, you're good, miss. X scale, make it whatever you want, but I don't like to see like too much clutter in the t-axis or x-axis. So I made it 5. Y min, well, we only go to -1, so let's go a little lower than that, like -3 or -4. Y max, it goes all the way to 13, so make it like 16 or 17. I'm going to make mine 17. Y scale by 5 maybe. And then don't mess with the resolution and delta x, the trace step size. Don't mess with that. And then push graph. And there it is. Oh, you know what? I know of a fancy feature. Yours didn't do that? What was the what? -1, 32, 5, -4, 17. All right, check this out, guys. Enter. Oh, man. That's not what I wanted it to do. Okay. All right, check this out. I need everyone to focus real quick. So, do we understand that this graph just shows you where point P is? So if I push graph, and I'm going to push enter. At that moment, frozen in time, is point P going up or going down? Going down. Is it above the water or below the water? Above. What about now? It's below the water, still going down. It's about to turn a page and start going up. And then now it's going up. Now it's going down, below the water, now out of the water. So do you guys see what's happening? And of course, it's going pretty fast right there, but that's fine. All right. Now, do we have any questions on how we graphed?
I graphed a straight line.
Oh, check your mode.
Oh, but the grid. Oh my god. Nice.
All right. So here we go, guys. We got that. We're good to go. Let's go to the next question. And it says, well, mine came up a little weird there, but that's fine. It should have been down here. How high above or below the water surface will point P be at time 17.5 seconds? At that time, will it be going up or down? So here's how you do it really quick. You see a button called trace? If you push it, trace. Now I can just push the number that I want. I want it at what, 17.5? So push 17.5 and enter. And it tells you where you are at, and it tells you the Y value, and it tells you where you are at on the graph. Do you guys see that? So you are bless you. Oh, that was nice. You are 0.657 feet below the surface of the water. And are you going up or are you going down? It looks like you're going up. If you want to zoom in to take a closer look, you can. So I'm going to write at 17.5 seconds, comma, point P is 0.6, I already forgot. Word. 657. 657 feet below the surface. Period. Point P is moving, or is going down. Is going up, sorry. Is going up at 17.5 seconds. To reiterate. There it is, full credit. We answered the question. No, it doesn't have to be perfect. I probably could have said at 17.5, point P is 0.65 feet below the surface and moving up or going up instead of, doing the way I did it there, but that's fine. Cool or not cool, guys? Look at letter D. At what positive time t was point P first emerging from the water? So let's look at our graph. We don't want this one here. I don't know if you guys can see my little arrow there. I don't want when it first went into the water. I want when it first went out of the water. Does that make sense, guys? So we just tell the calculator to give it to us. We're going to go second, calculate, and we're going to push which one? 0. And then when you do that, it's going to say, where do you want me to look? So I'm going to move the cursor. I want you to look between here, enter. And I'm going to go to the right of that value and enter again. Guess? Nope. And there it is. 7.8611 truncated. Does that make sense, guys? So I'm going to write point P first emerges from HOH. That's the same as H2O, right? When T equals
Sorry, this is like really that threw me off.
7.8611. 7.8611.
You put hydrogen monoxide.
No, it's hydrogen. It's water.
Sorry, hydrogen monoxide. Yeah.
H2O in liquid form.
Hydrogen monoxide.
But make sure the HOH and H2O is the same. You have two hydrogens and an oxygen.
But if it was water,
That
it's
hydrogen.
also okay.
Point P first emerges from water when T equals 7.8611 seconds. Cool or not cool? It is a scientific term, miss.
Okay,
Two hydrogens and an oxygen.
not like mechanical, like engineering term. I was like, is that a machine?
All right, here we go. And I think we're done with that. Cool or what? What's up? The what? Yes. Ready? Second, calculate. And then I put number 2, 0. And then it's going to tell me where do I look. So I want you to look between here and there. Guess? Nope. And I just push enter. You
That
see?
would be 7.8641 seconds.
Yes. Seconds. All right, let's go to the next one. Check it out. The next one looks cool. It's a roller coaster, guys.
Wow. I want to make a roller coaster now.
So you being a super awesome engineer, Fiesta Texas hires you to build a portion, just a portion, of a roller coaster track in the shape of a sinusoid. You've been hired to calculate the length of the horizontal and vertical support beams. So that's what you're doing. Letter A. The high and low points of the track are separated by 50 meters horizontally, and it shows you that on the pictures, and 30 meters vertically. The low point is 3 meters below the ground. Let y be the distance in meters. I don't know why there's a yo there. Erase that. Yeah, I did that on purpose, but at the time I thought it was cool. Now it's lame. A point on the track is above the ground. All right. Let x be the horizontal distance in meters. A point on the track is from the high point. Find a particular equation for y as a function of x. So before we start, make sure we understand what we're doing. Does this track look like a sinusoid? Yes. So that means we're probably going to have to figure out an equation for this portion of it. Does that make sense? So I'm going to zoom in on this track, and the first thing that we should know is that I have a low point. How many meters below the ground? So that is -3. And knowing that this stretch is 30 meters from the low to the high, that means my high is not at 30. My high is at 27. Perfect. Are we cool? Perfect. I think we know enough now to get the equation of this curve. What's easier to use? Cosine. Here we go. You guys ready? All right, let's see. What do you guys want to start with first? The amplitude? All right. Y equals, from low to high it is 30, so my amplitude has to be 15. Cosine, open parenthesis, the B. Well, from high to low, that's half my period, and it already went 50. So my whole period is 100. So 2 pi over 100. We'll reduce it in a little bit. No, we will. We'll reduce it. What's my horizontal shift? 0? So I'm going to write x minus 0 for now, but I'll delete it in a little bit. Plus, what's the midline? 12. It doesn't matter how you do it. You can go -3 plus 15, or you can go 27 plus -3, which is 24, divided by 2 is 12. Doesn't matter how you do it. You'll get it right. Cool or not cool? All right, so there it is. I'm going to rewrite it, reduced form. I'm going to put y equals 15 cosine, open parenthesis, pi over 50, x, close it, plus 12. Notice I didn't write the x minus 0. This is what we're going to be using over and over again, guys. So let's put this as our new y1. So go to your calculator, and I'm going to delete this one. And I'm going to type in 15 cosine, I already forgot, was it pi over 50? pi over 50 x, close it, plus 12. If you want to see it, here we go. I'm going to click on window. And I'm going to go -5 to, let's see, 55. 55. Yeah, we just need that little portion. X scale by 5, that's fine. Y min, I go 3 meters below ground, so I'm going to go -6. And then it goes all the way to 27, so I'm going to go like 32, 33. And Y scale by 5, that's, yeah, I guess that's fine also. No, let me make it by 10. All right, when I push graph, here's my roller coaster. There's my roller coaster, guys. Your graph should look like that. Huh? Oh, yeah, yeah. Superman's one of my favorites. I know it's an old one, but. Good. Does everyone's graph look more or less like this? Okay. So here we go. Let's see if we can answer some questions. It says the vertical support beams are spaced 2 meters apart. So that means these. So if I zoom in on this, these vertical support beams that I'm highlighting in red, let me highlight it in blue then. Highlighting in blue, those are 2 meters apart. Everyone should know how big the first support beam is. How big is the first one? No.
Oh, 15, 30.
From 27. The first support beam is 27, guys.
Wait, but it doesn't go underground.
It doesn't go, well,
Why would it go underground?
from, yeah, I mean, yeah, you're right. If during construction, I'm sure they build into bedrock and all that. But from 0 to the highest point, that's just 27.
Okay, but my question is, why is the roller coaster going underground?
It's just a little piece. Just a little piece is going underground. Yeah, like a tunnel. All right, here we go. We haven't. Let's see what it says. All right, guys. All right, guys. Focus. The vertical support beams are spaced 2 meters apart, starting at the high point and ending just before the track goes below the ground. Make a table of values of the lengths of the beams. All right, yes, you can look at a table on your calculator really quick, but I'm going to show you guys another way to do this. So write X and write height of beam. That's your Y value. At 0, it is what? 27 meters. I believe this was in meters. Then at 2, so how do I get that value? Watch. Go to your calculator. You guys ready? If you push the trace button and you push 0, so let's just use 0 to verify. Does it say 0.27? Okay, now the trace button's already there. You don't have to push trace again. Now you can just go 2, enter. And check it out. It gives you another one. 26.881. 26.881 meters. 4. So I'm going to go 4, enter. 26.528 if it's truncated. 26.528. How many should we put? Well, let's just put one more and then do ... That means continue the pattern. So I'm going to push 6, enter. 25.946. 25.946 meters. And I want to go all the way until the last 2 beams, right before I go underground. So Travis, how do I do that? What's already on trace, use your cursor and keep going to the right. Let's see, and remember it goes by even numbers, 2, 4, 6, 8. So it looks like I am underground at 40. Do you guys see that? So that means 38 is my last one. Yeah, you can. And then figure, and then 1 to the left. But I think this is fast. Well, it might be faster with S intercept. So there it is. So 38. So 36 and 38 are my last 2 beams. So 36, 2.438. 36, 2.438, and 38. Come on, buddy. 38. 1.065. 1.065. These are all in meters. Do we understand what we're doing, guys? Okay. Happy face. All right, let's go to the next one. I think yours, you're going to have to flip the page. Don't worry, we're almost done, guys. The horizontal beams are spaced 2 meters apart. Change that word to starting at ground level. Starting at ground level and ending just below the high point. Make a table of values of horizontal beams. Okay, so this is what we mean by horizontal beams. I'm going to put it in green. This is my first horizontal beam right there. Do you guys see that in green? That length is, I forgot what it was, 38 point something. I didn't find the 0 there. So let's see what that length is. Here's my calculator. Second calculate, I'm going to put number 2, 0. And I'm going to go left bound, yeah. Right bound, yeah. There it is, 39.7583. So that's my first one. So I'm going to go, what am I going to do? Y, and then horizontal beam length. Horizontal beam length. 0, and what was it again? 38.39? 39.758. How am I going to get the next one? I could put y equals 2 and then find the intersection and do that, and then y equals 4 and then find the intersection. Is there a better way? I think there's a better way. What was my equation again? My original one? Y equals... Can't we solve for x? And wouldn't that be better? And then we just type it into the calculator of the hack, into the y equals. You know what I mean? Yeah. All right, let's solve for x, guys. So what do I do first? Move the 12. Perfect. So I'm going to rewrite this on the left-hand side. 15 cosine pi over 50x, close it, equals y minus 12. Tell me what's my next move. Divide by 15. Divide by 15, divide by 15. So now I have cosine pi over 50x equals y minus 12 over 15. What's my next move? Inverse cosine. Good job. Pi over 50x equals, I'm going to put plus minus for now, but we'll delete it in a little bit. Y minus 12 over 15 plus 2 pi n. What's my last move? Perfect. That's a 50 there. So my final answer comes out to look like x equals plus minus 50 over pi, arc cosine, y minus 12 over 15 plus, let's see, the pi's cancel out, 100n. And then we're going to talk about what's appropriate here. You guys, I'll wait for you guys to all finish. Don't worry, guys, we're almost done. This is our last one here. Okay, does it make sense to keep the plus 100n? No, we only care about this little section, and that is it. We don't care about anything else. Does that make sense? And then do we care about a negative beam length? No. So we are not going to even bother doing 2 general equations. We're just going to use 1. Does that make sense to you guys? All right, we're going to do a hack. We're going to plot this into the calculator, into the y equals. We know it's an x, but we're going to plug it into the y equals. We're not going to graph. So I'm going to go to y equals, and I'm going to go to y2. And I'm going to type it in. 50 over pi. I'm going to use the fraction feature. In case you don't know where the fraction feature is, guys, alpha y equals enter, and you get a little fraction, see? You don't have to. You don't have to do that. 50 over pi. I think that's what we had, right? And then arc cosine, second arc cosine. And I'm going to use the fraction feature again, alpha y equals. I recommend you use the fraction feature on that, or use parentheses. On the top, I'm going to write what? X minus 12. We know it's a y, though. We know it's a y. And then over what? 15. And then close it. And I believe that's it, right? Okay. Don't graph. Don't push graph. Let's see. Do you guys want to see how to use the advanced feature? Yeah, you guys are smart enough. You see where it says table set, where the button window is at? Click on second table set. And since we know we're going to go every 2 meters, go to where it says change in table and change that by 2. Start at 0. And then leave this as auto and auto. Now, go to second table. That's where the graph button is at. Second table. And you just care about the red one, the Y2 here. And check it out. At 0, did it say 39.758? Yeah, that's the first number we got. Remember? Did the first one match or no? Yes. So now number 2, 36.614. So go back and I'm going to go, where's my table? 2. And I already forgot the number. 36.614. 36.614. Let's do 2 more. 4. 33.953. Dot, dot, dot. I want to get the last 2. What's going to be the last one, or the last 2? Yes, the last one's 26, because do I go higher than 27 meters? No, so at 28, there's going to be error. It better say error after. Good. Because that's how, it says error, you're not shocked, because it only goes up to 27 meters. So give me a 24, what did it say? 10.242, this is all in meters, and what does it say at 26? 843? 42? 44? I can't hear. 8443, like that. Okay, that's fine. All right. Yes. Yes. I typed in this equation. Of course, we know that y2 is actually an x. So x equals 50 over pi, arc cosine, and I know that x is actually a y, but that's my hack, right, to get this into my calculator. X minus 12 over 15. And then from there, I just went to my table, second table, and I just care about this one in red. You know what I mean? Now, I told my table to go by 2s. You don't have to, by the way, guys, there's other ways to do it. For those that like to be, like maybe, a long time ago, he was a very bright kid, but this was too much for him. Like, you see how there's a lot of numbers? Like, oh, Chava, this is too much for me, this is too much for me. And this worked for him, like, super awesome, because he didn't like to see all those numbers. So I go, okay, second table set, your calculator is going to be an ask all the time. And it helped big time for him, because then when it went to table, look at that, it's clean. And this, for whatever reason, like this helped him. Like, oh, okay, I want it at 0, enter. Okay, that's the number I'm going to put. I want the next one at 2. That's the number I'm going to put. The next one at 4. And it helps. Maybe you don't want to see all that numbers all over the place, and like you just want to see just a few at a time. Then you can do that. You can tell the calculator to do that. Cool or not cool? Okay. All right. And the last question, and don't worry, we're kind of going to give this question to you guys as homework here. Or see if you guys can figure it out. So, no, don't worry, guys. Come on, we got to challenge you guys. You guys are smart. It says, you must know how much support beam materials to order. In the most time-efficient way, find the total length of vertical beams and the total length of horizontal beams. Okay, guys, I know that we can just go a cell at a time, add, and we can do that. for all the cells. What I mean by cell, every single rectangle, every single one of these. I know that I can add them all up. Y1, Y2, we can do that. But is there a fast way to do it? There is a fast way. And I'll probably give you the answer on the next class session, but I want to see if you can figure it out. Because you guys are going to be the future, right? And you guys are going to be the future engineers, future doctors, and I want to see if you can figure this out. Cool? So, yeah, like, okay, they want to know how much total beam I have. And you can add up all these cells one at a time, but can you do it fast?